Yeah. So yesterday I told you we are telling discussing when you use class, when you use subclass, when you use abstract class, when you use interface. One more simple formula I give you to decide when to use which data type. Okay. So see this. We want to code, means developer wants to code now. His intention is what? He wants to code something. In Java, if you want to code, before you code, first check whether the code exists. Okay, is the code already ready there or not? First check that. Okay, so there will be two options. One, code exists. Okay, code does not exist. Means code will not be there. You want some logic, but that logic will not be there. These are the two scenarios you'll come across very commonly. Code exists. Okay, so you're happy with the code. You're happy with it. So what will you do? Directly create object, use it. Means bring the code into existence, use it. This is the first case. Understood? Directly create object. Okay, I will take all the cases now. This is the first case. Another case, code is existing. You want to modify it. Okay. So the second case would be you want to modify. Now modify can be what? Modify. You want to modify existing code. Remember that. You want to modify existing code. Now existing code can be what? Modification of existing can mean what? Adding or changing, anything it can be. So when that happens, that's when you start using what? Yeah, use subclass data type. Understanding now? Use the subclass data type. Now code does not exist. So now you have three options here. Okay, code does not exist. You have three options here. What are the three options when code does not exist? One. Okay, we'll continue. Third option. Okay, you want to write new, completely new code. Understood? Completely new concrete code. Okay, so write completely new concrete code. Okay, so what will you do? You go for a use class data type. See, you should know when to use subclass, when to use class. Okay, so the fourth condition now, you want to do partial implementations. You are following now? I think it's correct, but I'm running short of space. But is it okay for you if I write like this? 1 second. Everything is correct. 1 second. Just I'll take the classification from here. What is the first thing? Write new concrete code. So for this, the third case, what will you do? Use class data type. Okay, third one, the fourth case now. Fourth case would be what? Do partial implementation. Means you want to write a new code. You want to write a new code, but you want to write it partially. Understood? So write partially and set the standard for what? Others to implement now. So write partial code. Write partial implementation. So that is when you use what? Abstract class data type. Lastly, okay, you want to write a new code only. Code is not existing now. Understand the scenario. Code is not existing. 1 second. How shall I shift this? You're following this now? What is that I had written here? Code does not exist. You want to write code in Java. If you want to write code in Java, or if you want to code in Java, this would be the case. What is that I had written? Write code in Java. There will be two options. First, check whether the code exists. If it is not there, then this will come. Okay, now you want to do no implementation. You want to write a new code. You want to write new code. Following? No, but you do not want to do implementation. Understood? No, you do not want to do You want to write newly. So that time you'll choose which data type? Interface data type. As simple as this. Use interface data type. Is it clear to you now? So before you start coding, first check, and this is what we'll be seeing now in the library. So this means actually we'll be seeing the library now. In the library, if the code exists, we will use it. If it is not there, okay, then we'll think of all those options. Are you clear? Means you want to write a new code, write class. If you want to do partial implementation, you will write abstract class, and if you do not want to do any implementation, use interface. Understood? So this will be the story now. Subclass, class, abstract class, interface. So these are the 4 data types now. Data type number 1, data type number 2, data type number 3, data type number 4 provided by Java. All are rich data types provided by Java. Yes or no? Very rich. They can store data also, plus they can implement OOPs also. Your C language also is giving you, see, I told you one thing very clearly. Which language is very successful while programming? Okay, a language it gives you, most importantly, user-defined data types. So developers need user-defined data type. There's no doubt about it. So a developer always chooses a language which provides the support for user-defined data types. There's no doubt about it. Understood? But we want the support of the user-defined data type also. Plus, what we require, it should be powerful. Okay, and it should be user-friendly. And you're seeing the power of all this. They are powerful, and at the same time they are user-friendly. In C language also you get, example I am comparing now. In C language also you get the user-defined data type structure. Okay, it is not powerful like this. There you cannot implement OOPs now. In your C user-defined data type, can you do anything? Nothing you can do. It's a simple data type which can only store data. Apart from that, nothing it can do. Understood? Apart from that, nothing it can do. The next thing is, one more thing is, it's very difficult to work also. Because to work with your user-defined data in C, we have the headache of pointers. So here to work with your user-defined data type, nowhere you saw what? Pointer. Understood? So here we call them as reference variables. That's it. Here the pointer concept has been eliminated and replaced with a nice word, a very simple word called as reference variable. And the reference variable is very neat and clean. If you see, the reference variable is of type what? You can use that reference variable to work with that type of the data type. If I am having A example, now A can work with A data type. Box B can work with box data type. But in C, if you see pointer P, you will not know it is having the address of which user-defined data type. Full confusions will start there. So this is how they have summarized everything. Are you clear with all this now? So Java's user-defined data types are rich. What are the advantages now? What are the features of Java's user-defined data type? Features of Java's user-defined data type. What are the features? First feature, they can store data. Yes or no? Your user-defined data can store data, you know. Class can hold data, subclass can hold data, abstract class can hold data, interface also can hold data. Understood? So all of them can store data. That's one thing. Second, you can use them to implement OOPs. You can use them to implement OOPs. Now, very user friendly, there's no doubt about it. So they are rich. Then next, they are platform independent. You'll write some code now. It is there in the class or subclass, where it is. Now that dot class can run in any operating system now. That is the most powerful feature of this. Okay, see, in other languages you will write all the code. In C, supposingly, you might say C is also giving a user-defined data type which is very much similar to this. But the user-defined data type in C, the user-defined data type in C++ also supports what? It can store data. It can be used to implement OOP. But it is not user-friendly. It is not user-friendly. C++ it's not user-friendly. Understood? And at the same time, it is not platform independent. Portability. Understood? So we are talking about platform independence or portability. I'll take it in a simple word, portability. So these are the two features which your C++ data types lack. See, C supports only this. Yes or no? C supports only this. C++ supports what? Only? See, this only C. Now C++, okay, it can store data. Your C++ can be used to implement OOPs, but it is not user friendly and they are not portable. So C is only, it can store data. C++ also can store data. Java also can store data. Okay, this is common feature among all the three. Okay, C++ also can implement, oops, Java also can implement oops. User friendliness when it comes, it is only Java. And finally, portability if it comes, it is again only Java. So still more features are there, which makes Java's data types very rich. Understood? How much of words I used to explain it, it is less only. Understood? Whatever words I have, or whatever words are in the dictionary, you pick out. Still, it is less only to explain what? The power of Java's data types. They are very rich. And we start using them. When we use it, you'll understand. Are you clear with this? Okay, so you cannot say Java is a tough language. It is the most easiest language on earth now. On top of all this, what they are doing? They are giving you libraries, full libraries. They are saying do not code, do not code. We have got sufficient libraries for you to work. Why they provide libraries? Only one reason. Because the data type is portable. The classes and all, what the built-in classes, like example, string buffer. Most of you know, system, yes, use some of them. Okay, these are the .class files we will be using later, built-in libraries, which can run in any operating system of the world. Some examples I told you, plenty are there. Okay, that's how Java is becoming a very powerful language. And it is unbeatable. You don't have to worry, after 25 years what will happen. Understood? It will be there. Java cannot be replaced. Why means, see, if anybody wants to learn, means if even a new language comes, the problems are, what will be the problem? Developer has to get, first he has to get, means first people should be comfortable about that. Supposingly today a new language comes out, now nobody is ready to learn that until unless somebody tells you. But who is going to tell him to learn? Question is that now only if he is having experience and all that, then he'll tell you to learn. So people are not ready to migrate only in the first case. Second case, if it comes also, okay. First is people are not ready to migrate. Second thing is, in Java there are so many libraries, developers are addicted to this now. They don't want to leave this rich platform and go and learn what? Another new language. So these are the various reasons, and now on top of that there are thousands of millions of projects which have already been coded in Java. And they are always under enhancement and maintenance. Now those projects, they will not remove all that code and write new code in new language. So these are all impossible things what you are thinking. Understood? So Java cannot be replaced. Understood? So for big huge applications, Java is mandatory. Small time applications and all, they can use small languages, but that small application, when it becomes a big application, again they have to migrate that application into Java language itself. So that powerful and robust it is, and slowly you start understanding it. I only explained you the data types. Slowly you'll start understanding more features of Java. Are you clear with this? Okay. So do you have any questions till now? Difference between all the 4 data types is over. So in the interview you have to tell this much. What? Yesterday's points on the last class points. Plus this I have already told you. Okay, just I highlighted it. This I already told you. Just so remember, from the interview point of view, what topics are covered is more than sufficient for you to clear in the interview. Clear? Any questions? Any questions? No questions? Okay. Now I'll show you how to use interface as what? Same thing. Argument, parameter, return type I'll show you. Okay. Then almost all we are done with interface. Understood? I'll show you how to use it as what? You can use an interface. You can send an interface also as what? Argument, parameter and return type. Same old story. All 4 data types you can send. Understood? Any data type you can send as argument. Any data type you can send as return type. And why do you send user defined data type as arguments? Multiple values. Remember that. Multiple values. That's the first thing. And lastly, when you are sending user defined data type, it is always called by reference. Are you following now? Okay. Shall I clear all this now? Same. Remember, arguments and parameters. This is the main thing, because when you work with libraries, this is very crucial thing now, because there will be ready-made code. To invoke the method now, you will have to send arguments. That's why I am stressing so much on what? Arguments and parameter, because otherwise you can't work with your libraries. Understood? That's the main reason I am focusing on this: arguments, parameters, and return type. Arguments, parameters, and return type. Remember now. Okay. See, all data types. First of all data types can be used for what? Can be used as arguments, parameters, and return type. Remember the first thing. Now, again, all data types means what? There are only two types, broadly classified, primitive types and broadly classified. Understood? User defined types. I need space, just a second. All user means there are two types of data types. Primitive types means which are given by the language. Other one would be user defined types. Okay, now here it is always called by value. Remember that. It is always called by value. Here it will always be what? Called by reference. Now why do you send user defined data type as argument, return type and all that? Because we can send multiple values. That's the main reason why we use user defined data type. We can send multiple values. Okay, so there it is called by reference. Here it will be called by value. Now examples for primitive type, yes, you know now. Byte, short, int, long, float, double, boolean. Eighth one is char. For all this it is what? Call by value. Okay, for user defined data types. Okay, one more I'll say here itself, derived types. User defined and derived. Derived array is there. Understood? So I'm classifying it like this. Or you want, you bring derived here itself somewhere. Okay, so fine now. Which are there? One is array. Second one would be class. Third one would be what? Subclass. Fourth one would be what? Abstract class. Fifth one would be what? Interface. So for all this, what happens? Call by reference. For all this. Very simple formula, man. And this is, we call it as, it is classified under derived type. And all these are classified as user defined type. That's it. If you are perfect with this, you are done in Java. Because only we have to go on using libraries now. They are ready-made methods which we go on invoking now. So to invoke that method, what you have to send, that's all you have to understand. Are you clear this now? Remember this formula, only then you can move ahead into library. A very simple formula I have given you. Clear? So now I will show you which one. How to use interface as argument, return type and parameter. That's it. Argument, parameter and return type I will show. That's it. Clear? All data types can be sent as argument. Remember the first thing. But these data types can be used for your implementing user defined data type used to implement Never forget that. Class can be used for what? Implementing now. You can use a class for doing what? Encapsulation, inheritance, polymorphism, abstraction. Same thing. Subclass also can be used for doing all the four. Abstract class also can be used for doing all the four. Interface also can be used for doing all the four. Why is Java again so many data types? You know now. Because it depends on scenario. Understood? It depends on scenario. What scenarios you know now? When to use class, when to use subclass, when to use abstract class, when to use interface also, you know. Understood? Are you clear with this? So shall I start off now? How to send interface as an argument? I think you should be able to do it now. Is it clear? But practice this, because this is most important example what I am showing you now. Which one? Returning an interface. Returning an interface is understood by people with 3 years of experience. You will not believe it's coming out to you so easily. Understood? See now, I have an interface. Interface name is, I'll take one name by name, interface by name, animal. You can give any name, that's your wish. I'll have two abstract methods. One is void sound, another one would be void eat. Here I am making both as abstract. Both as abstract. Okay. Now, generally when you implement an interface, you know how you do it. You say class animal, correct? Means you have to give a name. You have to give a name. Generally, we take the same name of the interface. This is the practice, tradition what we do. Whenever you want to implement an interface, we take the name of the interface, same name of the class we'll give, but we add the suffix called as IMPL. That's the tradition, means standard, coding practice. I can go for a different name like A, B, C, D, yesterday I showed you. But now it becomes, when you look at the class name, it's very clear. This class is implementing that interface. So always follow this standard. Always follow this. So class animal IMPL implements what? Yes. Are you following now? Animal IMPL is the name of the class. Okay. So here you have to give the body for the two methods. Public void. Okay. I think here it will not suit that. I think this standards I'll teach you later. Okay, but just understand, anytime when you are implementing an interface, you go with what? IMPL. I'll bring those standards later because right now it will be a little uncomfortable for you. So I'll go with this thing now. Just see this. Class dog implements what? Animal. Class dog implements animal. Public void sound. Okay, so here you have to do what? SOP. Dog is barking. Public void eat. SOP. Dog is eating. See, the topic is what? Just do not forget this. We are using how to send interface as a argument, parameter and return type. Using interface as, this is very, very important, argument, parameter and return type. Okay. Similarly, you can have what? Another class. Class lion implements what? Animal. So it goes on. Public void sound. SOP. Lion is roaring. Public void eat. SOP. Lion is eating. Anything you can write. See, interfaces always state what they do, but not how it is done. You know all this. So now what I'll do, I'll have class hello. I'll have an M1 method here. I'll have a parameter of type animal. Following now? So what is animal now? Interface. I'll be sending it as an argument. Very simple. You know all this now. So it will be what now? Heading is this. Okay. So now when you get the value, what will you do? You can call it z dot sound also you can call, z dot eat also you can call. Getting it now? So this is class hello. Now I'll say class demo PSVM say this. Now I'll create the object of hello, h is equal to new hello. Why did I create it? Because I wanted to call which method? M1 method. My intention is to call M1 method. So I have to create an object of hello. Correct now, because it's an instance method. So this is how we work. Because when there will be so many classes, you should know how to work now. So now what will I do? I'll create an object. So once I create an object of hello, see M1 is getting, on M1 method comes into existence. There's no space here. In small I'm drawing this M1 method animal Z. Yes or no? So here I'll call what? Z means whatever code you have written, same code comes into existence. Z dot eat. You have created an object of what? Hello. The address of this object is stored into what? The variable by name H. Correct? There is no problem with this. But to call M1, you know Java is strictly type checked. Simply if I call H dot M1, what will happen? It will give me error, no? We have to send an argument. See, Java is so clear about it. So you have to send an argument of type what now? Animal. But I cannot create an object of what? Okay, see now. I can declare a variable. Animal A is equal to null. I can send now H dot M1, I can send A. But what is error I'll get? Null pointer exception. Very simple. You are giving the null value. But what I should give her? A is equal to new dog. Valid now. Or I can say new lion, new cat. One more class if you want. So now when I say a new dog, which object is created? Dog object. It is referred by what? A. What are the members of dog? Sound and eat. These are the members. What is the reference value? 250. Some address will be there. That address is stored into what? A. The value of A, I want to give it to what? Z. Same thing, but the variable is in different scope. If the variable, see, you want to give the value of one variable to another variable. Very simple. Understood? See, if it is local, what would I have given? Z is equal to A. Supposingly, I have got one more variable by name animal Z here. If I want to give the value of A to Z, what will I do? Locally you assign like this. But if it is in a different place, out of scope, you will send it as argument. Very simple. So what will I do now? See, this was error. Sorry, it will give a null pointer exception. But it is valid code, it will compile. This will compile. Okay. See, here you will get compilation error. If you don't send any argument, int and all that, if you send, you will get error. Here it will compile. But during runtime, you will get the problem. So now, okay, just leave this. If it is local, you will do like this. How will you do? Z is equal to A will do. But now since it is in a different scope, H dot M1 of A I will send. Finish now. Finish now. Nothing more than this. So the value of A is given to what? Z. Now who will refer to this? Z also will refer. If you want to print the address, print the address. What will print? Same address. So now you can, and okay, anyway, it gets executed also. What will it print? Z dot. See, here you are calling Z dot sound. Which sound will execute? Barking. Z dot eat. Dog is eating. Now, next, I don't want to send dog object. I can send what? Lion. Fine. Now, which object has got created? Lion object. What are the members? Sound. Eat. But here, sound is barking. But here, sound is roaring. Means the implementation is different. The implementation is different. Yes or no? So now what will happen when I say h.m1 and send A? Now A was referring to which object? A will be referring to lion object. So when you send the lion address, so Z will refer to which one now? This one. And now it will print what? Same methods, but it will be calling what? Roaring and lion is eating. Dynamic polymorphism. Pure good example of dynamic polymorphism. Are you following this now? So you know how to send interfaces and argument now? How does it work? Call by reference. Check out. Print the address. SOP A you print there. SOP Z you print here. Over. Understood? So you can send an interface as an argument. Fine. Now I show you as a return type. Very simple. What is there? M2 method. Return type is what? Animal. So what are we doing now? Returning an interface. So you should know how to send. You have any questions with arguments and parameter of interface?
Dog has extra method.
You cannot call. Her question is, if dog has an extra method, that time you have to typecast. With Z I can't call. That is going to continue. Superclass variable can refer to subclass object. What members I can access from the object depends on the type of reference variable. Which one gets accessed depends on the type of object. But if I want to access subclass member, I have to cast. Yesterday I showed you casting. Now how do you cast? Before casting, what do you do? Use instance of operator. Before casting, use instance of operator. This I had completed in what? Abstract class. Yes or no? Almost all same. Still any questions? I can use instance of here. Means if you want to really call the subclass members, type cast. But don't cast directly, because you will not know which subclass object is coming. Understood? You will not know which subclass object is coming. That's why before casting you use instance of. If A instance of dog, typecast to dog. If A instance of lion, typecast to lion. Else if A instance of cat, typecast it to cat. And in that else if block you call the subclass members. Understood now? In that else if block call the subclass members. If you want, I'll show you that also. Clear? Typecasting I'll show you. Clear this? Let me show you now which one. Return type as animal. Any other questions here? It's very simple. This is also very important. These two are very, very important examples. Do not neglect this. I'm telling you very clearly, because if you want to work with library, here it looks very, very simple. Understood? It looks very simple. What is so great about this? Because when we work with libraries, we will send some subclass object, and that variable will be working with our object. I told you, interface to the object. Now what is happening now? This has been used as a interface to work with what object? Lion object, dog object. It has been used as an interface. That's how the data type gets the name. Interface is used to work with what? Always general English, complexity. Now you are using this as an interface from English point of view. You are using animal as an interface to work with the complexity of what? Dog and lion, or even cat, or even anything else. That's how it gets the name. Clear? Clear? Still any questions? Return type I'll continue. Return type is very simple. Write whatever code in the world you want. Whatever you want to write. Okay, 1000 lines you write, 10,000 lines you write. Finally you should return what? Animal. Finally the return type, you can have many variables here. A, B, so many variables you can have. But finally the return type of this should be animal. So okay, so just I'll write now. Animal A is equal to new, which one? Dog or whatever you write. Finally you'll do what? Return A. Finished. This is the class. Shall I remove this class? Shall I remove this? I'll draw it here for you if you want. See, hello class. When I create an object of hello, how many methods are there now? How many methods are there? 2 methods. M1, animal, Z. Okay, Z dot sound, Z dot eat. Now there is one more. Return type is what? This is void. This return type is void. Now the return type is what? Animal. This is M2. Following now? That was M1. Return type is void there. This is H object. Here what is the code you have written? Animal A is equal to new dog. Return A. Understood now? I'll clear this. I think now when you call h.m2, what will happen? One object of type what gets created? Dog. What are the members? Sound and eat. I'm showing you returning. So A will be referring to this object. What is the address? If this is 150, this will be 250. Returning an interface. We are concentrating on that now. So now if I call h.m2, what will happen now? Object is created. Same reference value will be given. I'll accept it. Animal A1. Any variable name you use. That's your wish. Now the reference of this A will be given to what? A1, and A1 also will refer to the same object. That's it. So again you can call A1 dot sound, A1 dot eat. So we'll be working with which object now? Dog object. But if I want to return some other, change it here. If I want, I can return what? Even lion. So that time what object gets created? Lion object. So A will be working with lion object. So sound and eat. Return A. Now this time we'll be working with which object? This is also same, dynamic polymorphism. So when you are returning, either you return what? Lion object, or you return dog object. That depends on. Both you can return. Not only that, cat also you can return. But return type doesn't change. It will always be what? Animal. Return type will always be animal itself. You can return dog, animal, cat, anything like that. That's your wish. Are you clear? So this is what you mean by returning an interface. It's a very important concept. This concept is called as what? Returning an interface. Very, very important. Now you might have some question. Okay, why it is called as returning an interface? Okay, if I ask you what is the returning here, see now, just very simple I tell you. You know, you write a method. This is called as what? Name of the method. This is called as parameter. This is called as body. This is called as what? 1, 2, 3, 4. You have 4 parts of the method. First part is called as return type. Second one is called as name. Third one is called as parameter list. Fourth one is called as body. Now if I ask you what is the return type of this method, what will you tell? Animal. Correct? Animal. It is. You will not tell me the whole story here. I am creating an object of lion, holding that reference value in A. I am returning A. You will not tell me this story. If I ask you in simple words, what is the return type of this method? All you are going to tell me is it is of type animal. But if I ask you what is animal, you will tell it's an interface. That's it. So what is the return type of this method? Interface. Understood? Simple. See this. If I ask you what is the return type of this method, see int x, int y are 2 parameters here. Here you will write int z. Z is equal to x plus y. Return z. You are writing this logic. Now if I ask you what is the return type of this method, will you tell me the story inside the method, or will you look into this and tell me? You will only look into the return type. Okay, you will not tell me there is a variable called as z, it is adding 2 numbers, it is storing the value of that, I am returning the value of z. Nobody will tell me the story. What is the return type of the method means one word you will use is, you will see here and you will tell int. Same here, what is the return type of this method? Animal. What is animal? It's of type interface. That's it. So that's how we tell returning an interface. Are you understanding the concept now? Very important terminology. This is a very important terminology. Why I am stressing on this, later on you will understand. Understood? Example, practical example. Driver manager dot get connection. It returns an interface called as connection. Yes or no? You write the code now. Connection is equal to driver manager dot get connection. You write this code where? In JDBC. Now what is connection? Interface. What is driver manager? Class. What is get connection? Static method. So this is how you should know how to use the library. So if I call the static method of called as get connection in driver manager class, it returns me what? An interface. Are you following the code now? So this is how you will be understanding the code later. So you should know how to use the libraries. Same thing here. If I call h.m2 method, what is happening now? It is returning me an interface. And with animal, what I am doing? I continue to code. A1 dot sound, A1 dot eat. Yes or no? Generally you say what? Connection con is equal to driver manager dot get connection. Con dot create statement you tell now. Same here. Connection is replace it. Connection con is equal to driver manager dot, those are from events and all, don't worry, we'll be learning this. Driver manager dot get connection. Same way, no, this is a class, you're calling a method, return type is what? Connection. And then you'll call the method now, con dot create statement. That's how the coding will start off. And I'll be explaining this very neatly in JDBC. You don't have to worry. But this concept is called as returning an interface. And we'll be using this extensively in programming. Next line you write, con dot create statement, returns what? Another interface statement. Then you'll write st.execute query. What will happen? It will return another interface. Like that, coding will go on continuing. Understood? You'll not be seeing any more code like what? Int a is equal to 1, int a is equal to 2. So we'll start using the libraries like that. So you will understand why I've stressed so much on all these topics later. If you're comfortable with this, you can easily move into the library now. You'll not have any difficulty. Are you clear with this? Just one practical example I told you where it is applied. Understood? Where is returning an interface practically getting applied. That's what I told you. Clear this? Any questions here? So you understood how to return an interface? Shall I type this and show it to you now? Understood? Very important. Even if you say no, I'll type it. Reason is it's so important. So important. Understood? Shall I clear everything? See, anything I told about JDBC, if you're not followed, you'll be understanding it later. I'm just setting the platform for what? Further steps. Don't worry about JDBC and all that. Just understand here how to send an interface as a topic is what? That you concentrate. How to send interface as argument, how to send it as, accept it as parameter, and how do you send it as return type. Okay, we'll start off typing. Interface, argument, parameter and return type. Argument, parameter and return type demo. Clear this? Interface, argument, parameter and return type. I cannot give comma here. Why? In an identifier you cannot use what? Comma and all. You can use only what? Underscore and dollar. Do not forget all that. Anyway, just highlight it. So interface, argument, parameter and return type. Some people will try to use comma. So that's why I just done. So we'll have one interface by name what? Okay, it will compile now. There is no issues with this. Now I have to go on implementing. Class lion implements animal. So we have to give the body for both the methods. Okay, I written class called as lion, and for both the methods you should make it as public. Okay. So next what will you do? You have to write the class. Any number of classes you can write now. When a class is there, sorry, when an interface is there, any number of classes can implement that interface. Class, what will I do? Dog I'll take. Dog is barking, you can take. Dog is eating. You can write more, but just let me cut it off. Okay, now I want to use it as what? Argument and parameter. So I'll write class hello, class hello. So next what will you do? You can have an M1 method, but the parameter is of type what? Sorry. First learn argument parameter, then you go to return type. I don't think I'll write off one more class. Cat I'll write. Class cat implements animal sound. Cat says meow. Okay. So animal Z, now what will I do? I can call Z dot sound. Z dot heat now. So fine. So you got this. So you are concentrating on this hello class now because we are sending it as argument. So now let's see how do you send it. Animal A is equal, sorry, first is equal to null. Oh, okay, first I'll take hello. hello h is equal to new. I've created an object. See, if I want to call m1 method, it's an instance method. Compulsory I have to create an object now. So what will I do? I'll create an object. After creating the object, what will I do? I can call the method. How do you call that method? h dot m1. But can I pass one int value there? What will happen? Compilation error. That's a second semicolon. Where? How quick you are in semicolon, man. Really, God only. God has designed you for identifying semicolon. Huh? Okay. So now we are getting that error. What? h dot m1. And now what is this error? Semicolon, huh? Okay, so you are sending a wrong argument. Okay, Java is strictly type checked. See, in other languages they compile, but during runtime you start getting problem. The beauty of Java is it reports these errors during compilation time. Java is strictly type checked. Okay, if I don't send also means I'm sending an int value here. You understanding now? It's something like this. Int p, take it like this. Int p is equal to 10. It is giving me error now. Why? Java is strictly type checked. So this is error, fine. But I cannot send int or okay. Then next, I cannot send any other data type until and unless it's of type animal. Very simple. So what will I do now? I declare one variable of type animal. See this, and I can send a, and now see what happens. End of main. I'll print here end of main. Here I'll print end of m1. Just see, program gets terminated. This null pointer exception is a big headache always. Begin, it will begin, but it will terminate here itself. The program terminates. Both these will not print. Which one? End also will not print. Begin will print. See this. Hello world print will not. Hello world will print. We'll remove this. No more confusions. Okay. Hello world will print. Object is getting created. I am calling the method. Till here it will execute. Once it goes here, this will also execute. But here, null pointer exception occurs. Some exception occurs. Understand that. And program terminates. Program will terminate. Okay. Means compiler is only checking are you sending an argument of correct type. Compiler is not checking what? Whether you are sending an object or not. Because objects are created during runtime. See this. Null m1 is begun. Hello world has printed. Begin hello world prints. M1 you have invoked. Control shifts here. Begin of M1 is getting executed. But after that it is failed to execute. So you can solve this problem. How will you do it now? A is equal to new which one? Any animal you send now. Lion. Perfectly valid code. See now what happens. Lion is roaring. Correct? Yes or no? You want change. Dynamic polymorphism now. The best support of dynamic polymorphism you are seeing. Cat. So what is saying? Cat says meow. Correct? Then what? Which animal? Dog. Oh, bow no. Dog is barking. As simple as this. Understood? So this is dynamic polymorphism. Are you clear? Okay. If you want, you will see the address. We'll print the address here. Dynamic polymorphism is a very important subject. Just highlight, just focus on this plus a. This value and here value of z value both will be same. Value of z. Simply that plus I put for what? Highlighting, nothing else. See the address, both the cases they are same. So it is called by reference. So you can send any data type as argument. Understood? Primitive or user defined. User defined will be called by reference. Primitive will be called by value. Advantage of sending user defined data type as argument is multiple values. That's it. Are you clear? Okay. Next, coming to casting. See here, blindly you should not cast. Means you should not downcast. If you want to do downcasting now, okay, you should not downcast directly because any object can come here. Dog can come, cat can come, anything can come. And here the story is like this. Animal is an interface. Misho always implements like this. Which one? Dotted lines. So here lion is a class which is implementing animal, then dog is a class which is implementing animal, cat is a class which is implementing animal. I think we can cache this now. Can cache this, but you can't access subclass member. Depending on the type of variable, you can access. We have seen this. So if at all you want to cache, what will you do? Check with instance of. Caching, you do it like that itself. How you cache now? If, understood, z instance of what? Lion. Now typecast it to lion. Lion L is equal to lion of Z. Correct na? Z dot sound. Z dot eat. Here there are no extra members, but if you want to write the extra, sorry, L dot sound, L dot eat. If you have extra members, you try accessing it. Okay, so just instance of lion, L dot sound. If Z instance of lion, sorry. If Z instance of lion, typecast Z to lion. Correct? Next, what will you write? Else if. Z instance of dog. Dog D is equal to dog of Z. D dot sound, D dot eat. Correct? Else if, continue. You want one more, cat. Else if Z instance of cat. Cat C is equal to cat of Z C dot E. Correct now? So depending on that, the logic gets executed now. I commented this now. Here we are typecasting, that's it. There we are not typecasting. So depending on what you pass, if you want, I'll put one more SOP there. See here. Which condition executes your only answer? Begin of lion. Some star I'll put. Means that condition gets executed. If I pass lion, put SOPs on. Maximum SOPs you put. Begin of dog. Begin of cat. Now see which one you want, and then finally M1 will execute. I'm sending dog now. Yes or no? So which condition gets executed? See, everything works. Dog. Address, if you want to print, there also you print address. What is that? Value of Z. And if you want to print value of L also, same address. Value of this, which one? A. Value of Z. Value of L. Value of D. All will be same. So I'm passing which object? Dog. Dog condition gets executed. I'll pass which one? Lion. Now which condition gets executed? Lion condition. I'll send which one? Cat. And typecasting, if you want to access subclass member, then typecast and do all this. Else leave it off. Understood? If you want dynamic polymorphism, if you want only the support of dynamic polymorphism, don't typecast. Understood? And you can send any subclass object. That's the meaning of dynamic polymorphism, no? Okay, depending on the object, it has to get executed. So if you want dynamic polymorphism support, okay, then don't typecast. Okay, but if you want to access subclass members, then typecast. That is the decision you have to take. Understood? Any questions here? Which one now I showed? Arguments, parameters. Now what will I show you? Return type. That's it. And I believe you know how to send it now. What is the return type now? Animal M2. Parameter list you have. I am not having any parameters. If you want to have parameters also. Okay. So now whatever you want to write, this M2 method in which one now? This M2 method in class hello. M1 is over now. We are focusing on M2 method. Okay. So here what I should do? Animal A is equal to new what? Dog. Any animal you send, but finally I should return what? Compulsory I should return what? A variable of type animal. Perfect. Okay. So if I want, I'll put on SOP here also. What SOP I'll put? Value of A is A in M2 is understood now? Just we'll bring it here. Some spaces. Are you clear? So now we'll call this method now M2. So we'll comment all about which one now? Okay. We'll not work on M1 now. We'll work on what? M2. Okay. H dot M2. Yes or no? See, if I execute this program, it will execute. No issues. Understood? It is returning, but I am not accepting. Accepting is optional. But if I want to accept and execute that, I have to accept it. Understood? So accepting is always optional, but if you want to, see, return type is optional to accept. But if you want to really work with animal object, then accept. If you want to work with that value, it will return the value. If you want to work with that, then accept. So animal, I'll take, okay, anyway we have declared it. Earlier A was null, no? You print your SOP A, what will print? Anyway the variable names are same. Don't, or I'll change it here. Animal Z I'll do. Plus Z. Return Z. Okay, fine. See, if I print SOP A here, what will be the value? Null. Here it will print what? Null. After I call the method, A will be what? That address. And once it is initialized, means once it is referring to the object, I can call what? A dot sound also, A dot eat also. Valid now? As simple as this. See how the flow goes. We have created hello world prints. We have created object of what is the value of A now? Initially null. So this statement is getting executed. Value of A is null. It prints. Then we are invoking what? M2 method. Control shifts there. In this one M2, what is the object? Value of A. It's printing the third line. You can see value of. Okay, I didn't change A. That's it. You make it as Z. Value of Z in M2 is what? That address. And if you want, you could have used Z here. That's optional. Return. The control comes back to what now? Main. In main, you can see the value of A is what? Same. See here. In main now. Control is shifted back. After I call the method M2, it shifted back. So you can see this output now. Value of A is it printing. Then you can see what it prints. A dot sound, A dot eat. So dog is barking, dog is eating because it has returned a dog object. Understood? And end of main. That's it. Are you clear? Any questions? So if you want, you can change here. What? Lion. Finished. Which object do you want to return? You decide. You can return cat, you can return lion, you can return what? Dog also. Which dog, cat, what do you want? As simple as this. Are you following now? Returning what? An interface. Very important. Practice this a lot. Any questions here? No questions? Fine. I'll show you one more example. Okay. With interface. There are many examples I'll show you now. Work hard with this because when you work with libraries, we actually code like this one. We'll call some method, it will return on interface. We'll call another method, it will return something. Like that we go on working. Yeah? Okay. Fine. So what was the topic I covered now? Using interface as a argument, return type, parameter. Argument, parameter and return type. Are you clear with this? So interfaces help you in supporting dynamic polymorphism. Understood? Complete abstraction. You will not know anybody's object you can send. When you are sending it as an argument now, you can send any object. Lion object, cat object, dog object, anything like that. Fine. So fine. So this completes that. And now there is one point you have written in notes. See this. I will be giving you an example for this point. One point means an example. My documents are so powerful. Any point you take now, it's an example. So let's see one more point yesterday what we have discussed. I'll give you one more example for that. Okay, see here. It is used for decoupling, and I'll give you an example for this point now. You know these points of interface use. We have seen what is an interface, yes or no? All this you know. You written it, correct? How to write it, all this you know. When you come down here, you have written all these points. Interface supports multiple inheritance, you know that. It is used for decoupling, you know that. Declaration and implementation, it always specifies what a class, you know this point. It supports dynamic polymorphism, you know that. Okay, this also you know, it's a data type which can be used as an interface to work with object, you know. Okay, 2 points are pending. One is it is used for doing is a relationship, other one is, yeah, it is used for loose coupling. This point I want to explain now. What is the point now? This point. Sometimes there will be has a relationship between two classes. There will be has a relationship between two classes. So when this has a relationship, let's see how you can still decouple it. Clear? Okay. Some good example I show you. There you understand this. You understood this point now? I'm giving an example of this particular point now. What is that? Decoupling. You can put that in as decoupling the dependency between two classes. Decoupling the dependency between two classes. One class will need another class, but we'll decouple it now. Let's see how you do it. Decoupling the dependency between two classes. Between two classes, yes, this is hiding, but again continue. When there is has a relationship, very important subject. Okay, when there is has a relationship, generally what you do? You go for what? Instance variables, no? Generally when there is has a relationship, what you do? You go for instance variable. Let's see now. So let's take the same hierarchy here, what we had. We are having what hierarchy? You know, just now I wrote animal is there. That is implemented by what? Dog, cat, as well as lion. 3 classes are implementing it. Okay. Now, hello wants to use animal as an instance variable. Hello wants to use animal as a instance variable. Understood? So now you have to make it as a instance variable. Now I have option. See, one class needs another class now. Hello class needs what? It can need hello class actually needs dog class or cat class or lion class. That's the requirement. Hello class is actually needing what? These 3. Because why? These are concrete classes. You cannot create an object of an interface, but you want to create an object of what? All these 3. If you want, you can create it. So now see in M1, another example it is, don't get confused. I'm not showing argument parameter return type now. I'm showing you how you use an interface as a instance variable. Oh, okay, you can continue. Or one more word we can say is using interface as a instance variable. Okay, now see here. Now my intention is to, there are methods now. What are the methods here? Here you have got eat and sound now. These are the 2 methods and all of them are implementing it. Eat and sound. Eat and sound. Same in this one also, eat and sound. These are the methods. Correct? Now they are implemented. Now M1 wants to call method of which one? Dogs eat and sound. So let's see how you do it. So I'll have dog D as an instance variable. Okay. Now in the constructor of hello, what I'll do? D is equal to new dog. I'm initializing it. Either you, okay, or you can initialize it here, hard coding. D is equal to what? New dog. I'll take like that itself. Dog D is equal to new dog. Correct. And in M1 method, I can call the methods D dot eat, D dot sound. It will work. There's no issue. Understood? So now see this class demo. PSVM. I'll create the object hello. H is equal to new hello. So when I create an object of hello, what's happening? Hello object gets created. Yes or no? H is there. Now H will refer. Okay, sorry. D is there. There's a variable by name D. D will refer to which object? Dog object. And dog will have what? Eat and sound. Correct. Address might be 150. Now this M1 is there. Now here you are calling what? D dot eat D dot sound. Valid now? Okay, and the address of this object, which one now? Hello object. The address of this is hello object. This is dog object. The address of hello object is given to H. Till here, any doubts? No. So fine, I'll call H dot M1. What happens? M1 gets executed, and these two methods get. M1 will call what? Eat and sound. This is how it works. There's no issue with this. Has the relationship? Yes? Okay. Tomorrow, I don't want to have dog as an instance variable there. I want to change it to what? Lion, cat, anything. So what you have to do? You have to change everything now. Change, because it will become a headache. So better what you do? Better you always use what? An interface is always the best option. Whenever you have an option, okay, where you have a superclass variable to subclass object, preferably go with what? Superclass. It will help you in decoupling, because whenever you want, you can change the object. See, this one art. When you go with superclass variable, when you go with subclass, it's an art. It will come with experience to you. But just see how we can code. Later on, by experience, you will only come to know when we use superclass variable to subclass object, or when we use subclass variable only to subclass object. Now this is much better. Why? Same output. Now A is referring to which object? Earlier dog variable was referring. Now animal variable is referring. It can refer now. Fine. But tomorrow I want to change it to lion. What will I do? Only one place I'll change. Only one place. Hello H is equal to new hello. Now A is referring to which object? Lion object. Yes or no? A will be referring to this. If I want, I can make it refer to cat also. Eat and sound. You are, see, everything remains same. Just you are saying hello H, all the same. This is also same. But only one change you do there, you can see how much of things get changed now. You can handle your code so efficiently here. Maintenance of your application becomes much easier. Tomorrow you want something now, you can remove it and replace it so fast. In structural programming, replacing code is a big headache. Just check out. In structural programming, no, you know structural programming. If you want to replace some code, what you have to do? Remove that entire code, bring new code. Headache it is. Nothing you are doing. What you will do? You will simply make the variable refer to that particular object. Finished. Which object you want to work, it starts working. Means which code you want to work, excellently it starts working. You don't like this implementation, change. You don't like that, change. What do you want? Following now? So this is how they have designed this language. Excellently they have designed the language, which is very much helpful for any developer. Since you are not coded in any language, you are not having idea about all this. But if you have coded something, a real good application in any language, then you would have fallen in love with Java. That beautiful it is. Understood? Right now it is only one way love. Correct? Huh? Java is loving you, but you are not loving Java. Correct? That's the problem. So you start loving Java, it will also love you. Understood? You love Java, Java will love you now. You don't love Java, why will Java love you? So love, it will also love back to you. Understood? Two-way love it should be. Correct? Now always two-way successful or one-way successful? Two-way, then love. First you love, man, then it will love you. You should take initiative now. If you don't take initiative, how will it start loving you? Correct. Very rare case where somebody opposite person starts loving you. Correct? Huh? Java is very strict. It will never love anybody. Understood? If you love me, then I love you, it says. Understood? Any questions here? Any questions? Clear with all this? Excellently designed language. First see the problems in coding in other languages, and then you'll understand all this. Dynamic polymorphism support, why it is given, you'll understand later. I'm highlighting it. See, in structural, I'm not telling C. C follows structured programming. But all the structured programming languages, if you want to replace some code now, maintenance, I'm telling. Replacing code is nothing but maintenance. If you want to maintain it, it's very big headache. Full code you have to remove, something you have to do, something you have to do. What is executing, you'll get tired. Here nothing, you write on class. Give it there. Just attach it. Automatically it will start executing. What code you want, that only executes. As simple as this. Understood now? You understood the point now? Decoupling the dependency between two classes. Understood? Decoupling the dependency between two classes. Or other topic is when there is hazard means, okay, decoupling the dependency between two classes when there is hazard relationship. or other word is using interface as an instance variable. When you are using your instance variable as user defined data type, when you are using your instance variable as user defined data type, think twice how will you use it. Well, both are correct. Sometimes you'll use what? Subclass type, sometimes you'll use superclass type. Subclass is tight coupling, superclass is dynamic polymorphism, decoupling. Both are correct. I'm not saying see use only this. Both are highly valid. Some conditions will be there where you want to access subclass members. Do this only. Some cases will be there. You do not want subclass member. You want to support of what? Dynamic polymorphism. So whenever you want dynamic polymorphism, take the support of what? Superclass to subclass object. Whenever you want to access subclass member, that time what you do? Subclass variable to subclass object. But some cases will be there. Dynamic polymorphism support you want. Later on you want to access subclass members. Then do what? Downcasting or typecasting. Simple. Nothing difficult here. Very neat, clean, organized. Yeah? Any questions? No questions? You want me to show this? You can do this now? Yes, no?
Yes, sir.
Yes means I'll type and show. I'll type it off. Huh? This one I'll type. This is very important actually. Because right now you're not understanding how important it is. In application development, this becomes massive. That time you start thinking what is happening, where it's happening, which code is getting executed, what is happening. You start struggling so much. Because it is animal, dog, sound and all, no problem. Oh, I know it is getting executed, you'll tell. But when you start writing big applications, same concept will be used, but the method names will become little, which one? Project related. Like class employee, save employee, like that they'll become. That's it. Understood? So that time we'll start wondering now, because they will be seeing method names like what? Save employee, delete employee. Then you start thinking what's happening now. Understood? So that's why I show it to you. Should I clear all this now? So both are correct. Decision you'll understand when to use which one. This is the support of animal A is equal to new A is dynamic polymorphism. Dog D is equal to new dog is you want to access subclass member. Both are correct. Both are correct. Don't think this one is also correct. I'll use this one only, use this. What support you want, depending on that you choose. Are you following now? So here I'll write, see this. You will do this when you want dynamic polymorphism support. You will do this when you want to use access subclass members. Sometimes strictly you want to work with subclass members. That time you can do this. See, I'll take all this as it is. Interface, instance, variable, demo. Means using interface as what? Has instance variable or has a relationship. Okay. So what I'll do, I'll take this. See what I had written earlier, I'll take it from there, it's a previous example. So I'll copy this from the previous program itself. I got this now, lion, all this I've got. Only thing what I'm doing now is class hello, you concentrate now. Class hello. Yes, I'll have one method called as void m1 fine. Yes, now we'll have an instance variable. dog. First I show off animal only. Animal A is equal to new dog. A dot eat. A dot sound. Done. If you want, you can call begin of. Okay. So now see. H dot M1, yes, now you can see. I'm just calling M1 method, but it will create object of which one? Some new error you found out. Okay, dog is eating, dog is barking. I'll change this. What? Cat, that's it. See now, hardly one change. Now, maintenance is easy now. Any code I want, I can change. See this. Cat is eating, cat says meow. Okay. So now, which one? Animal A, new cat, which one? Lion, huh? Finished. This is also correct. This is what? Dynamic polymorphism. Next is what? Dog. D is equal to new dog. This is also correct. But generally this is done when you want to access subclass members. Here there are no extra subclass members, so it doesn't make any difference. Here it doesn't make any difference. Okay. So I'll use the, okay, now what will I do? D dot eat, D dot sound. So this will also work, no issues. But if there was subclass member, I could have accessed it. Example, D dot something like fun. It was there. Now it will give me error. It's not there. I could have accessed it. Okay. But now I can't change it to cat, because if fun method is not there in cat, you would have got error. With dog it will work, but with cat it will not work. So whenever you want to work with subclass member, better go with subclass variable to subclass object. Subclass variable to subclass object. When you want dynamic polymorphism support, superclass variable to subclass object. Both are correct. Situations will only in on a particular situation you will take one decision now. Clear? Any questions? This will give me compilation error because fun method is not there in what? Dog. Okay. And moreover, this also okay. I think done. We are done with this. Pretty much done with this. Okay. So that's also working. Which one? Using dog as an instance variable. Clear? Okay, I think we are pretty much done with interface now. Interface data type is also over now. Okay. But it has only two members. Most important of interfaces, sending it as an argument, returning it as a, having it as a return type. Argument, parameter, return type is most important subject of interface. Clear? Okay. See now some more topics I'll tell you about. This is from the OOPS design principles. Very high level for you. Okay. But somewhere down the line you'll remember this class. That time you'll remember me also. Okay. So this, from your fresher point of view, don't take it into consideration. I explained you all the 4 data types, difference between class, subclass, abstract class and interface. Now also I'll explain the difference between which one, all these 4 data types, but do not take too much into consideration if you are going to interview as fresher, because you can't justify the statements. But provided you are going with an experience, or if you are having experience of 2 years, 3 years, this is a very important concept for you. So this notes, if you read after 2-3 years, after you have experience of 2-3 years, it has heavy weightage. Now it's of no use provided you are a fresher, because you don't have the intention of learning. Right now your intention is very simple, you want job. Understood? But actually when it comes to programming, you will need all the support. When you get the job, no, all this you want to learn. That time there will be nobody to teach you. Understood? So that is why I'll just cover it off, because even if you get the job, there you will not suffer to understand that subject. There one by one point you'll start understanding. Okay, right now I don't know how far you can understand this. Okay, so don't bother much about this. Just write it down. Don't bother too much. If you're understanding, fine. I'm saying well and good. If you're not understanding, somewhere down the line you'll definitely understand. Clear? Okay, let's see this. See, first heading is a relationship between classes. You know you'll have data types now. So many data types you'll write. Class, subclass, abstract class, interface. End of the day, after writing them, will you keep quiet? You'll start using them. Now the only way to use these data types is two. If you want one class wants to use another class, what will you do? Either you'll go for has a relation, which I showed you now, or you'll go for what? Is a relation. There is no other way one class can use another class. First thing, keep this in mind. Because there are so many classes in Java. Thousands. Okay. One way to use it as what? Has a relation. Other one is using it as is a relation. Okay. Relationship between classes. One more way is there, but we do not take that into much consideration. You can send it as an argument also. You can send the data type as what? Arguments and parameters also. But we are more concentrating on what? Is a relation and see, one is if there is A class and B class. Two classes are there. Now how can class A or how can class B use A class? Question is that. Very simple. Three ways, only three ways. But we are more highlighting on two things here. Which one? Is a relation and has a relation. The three ways what a B class can use. See, requirement is B needs to use A class. That is the requirement. Understand first the requirement. B class wants to use A class. One option is class B can extends A. This is first option. Second option is B can have A as an instance variable. Second option. Third option is in B, if there is a function called as fun, it will have a parameter of type A. These are only three ways. One class can use any other class. Check out. There's no other way you can use it. Third option is you can use it as a parameter. And you should know when to use how. When there is a relationship, you'll go for inheritance. When there is has a relationship, you'll go for instance variable. Sometimes you'll not need both. That time you'll go for what? Arguments and parameters. These are only three ways. Remember this. Programming becomes very simple. Are you clear? So keeping this in mind, start thinking now. Okay. So I'm taking only these two into consideration now, not the third one. I'm not taking the third one into consideration. I'm only taking two things. Which one? Is a relation and see, this is a relation. This is called as has a relation. Understood? This is called as is a relation. This is called as has a relation. So I'll go more into is and has a relation. Parameter, no problem. Right now, no problem. Should I clear all this? Requirement was what? B needs to use, B class needs to use class A. Writing a class is not important, I'm telling you. Clearly understand this. For you till now what you are thinking, no, if I write a class it's great. Writing anybody can write. Using it is a talent. Understood? Because there will be thousands of classes written for you. Already ready in the library. Why? Nobody wants you to write the code. They just want to use it. And you should know how to use it now. Clear? Should I clear all this? I'll draw the diagram now. Which one? From the has a relation and is a relation, and I'll explain from the design point of view. Design point of view. OOPS design is there. See, OOPS is not related to any language. Yes or no? Many languages are trying to give the support for OOPS. Understand that. In Java, I did not teach you Java language. Till now what you thought? I thought Java language. I was teaching you OOPS in Java. I was teaching you encapsulation, polymorphism, inheritance and abstraction in Java. Don't think I was teaching which one? Java language. Now after learning this OOPS, you can learn which one? C++ also you can learn. Only syntax will vary. Same concepts are there in C++ also. So all the while I have been teaching you OOPS. Remember that. Okay, fine. Now, relationship between classes. What is it? One is going to be a is a relation, other one is going to be a has a relation. Yes or no? Relationship between classes. Okay. So when there is a relation, you go with what? Inheritance. Yes or no? When there is has a relation, you do it what? Association. Actually, it is technically called as, in OOPS terminology. In programming we say we'll make it as an instance variable. Understood? But according to OOPS we say it's a association. Now example for is a relation, see this. Like I'll say dog is an animal. So what do you do? First you'll write animal, then you'll say dog extends animal. Example for this. Dog is an animal. So how do you code this now? Generally you'll write class animal and you'll write some features, then you'll write what? Class dog extends animal. This is how it goes on. Understood? Now has a relation. How do you do it? See some of the example. University has a department. Okay, department has a lecturer. Or I'll just highlight this is and has a department, has a lecturer. Here also I'll highlight. Dog is an animal. If you want you can take more. Maruti is a car, class car. Maruti extends what? Car. You can take more examples. So Maruti is a car. So it should be a superclass car. Some common features you keep there. Class Maruti extends car. You're following now? How you do this? In has a relation, what happens? Let's see. University has a department. Department has a lecturer. When there is has a relationship now, there are two types of dependencies which get created. One is complete dependency. Other one is called as partial dependency. Now this one is complete dependency. Because department cannot exist without what? University. This one is called as what? Partial dependency. Example, okay, in OOPS terminology, complete dependency is called as composition. OOPS terminology, okay, partial dependency is called as aggregation. So this is, I'm telling you OOPS. I'm not teaching you Java now. Understood? Don't think I'm teaching you Java. Java is over. Yes, sir? Okay. So we are saying, how does Java give support to all these terminologies? How does Java give support for association, composition, aggregation? Then what is that? Some more are there. Generalization, realization, some more OOPS design principles we say. These are all called as what? See the OOPS design principles. In OOPS design principles, some words are there. Okay, first one, generalization. Next one, specialization. Then next, composition, association, aggregation. Then composition. Sorry, one second, you write here realization. Generalization, specialization, realization, association. Have you heard of these words? You heard, no? I'm just seeing. See, this is what OOPS is telling. How Java gives support to this? We'll start seeing. Association, composition, aggregation. Are you following now? Generalization, specialization, realization, association, composition, aggregation. Now see how Java beautifully goes on giving support to all this. In fact, I'm running short of space here. Yeah. In inheritance, again, there are two topics. One is called as generalization. The other one is called as realization. Again, this is in UML. This is called as UML representation. How do you do it? Represent it in UML, they say, generally. How do you do generalization? Generalization, sorry. generalization, and other one is realization. Generalization means we do extents. If you want to do generalization, we say we do extents. If you want to do realization, we use the word implements in Java. In Java, I'm telling now. In Java, if you want to do generalization, use extents keyword. See, other languages also are supporting OOPS. Okay, and they have to support all this. And ADA, Smalltalk and all are doing this. But I don't know which keyword are they using for supporting what? Generalization, realization and all that. Okay, this is from Java point of view. We do this, implements. Understood? And then, for doing generalization, the data type we use is superclass. Superclass is used for what? Generalization purpose. Yes or no? Yes or no? Yes. And one more thing, sorry. 1 second. Now how it is indicated? Extents means we always use the straight arrow mark in UML. For extents means we use straight arrow mark. For implements we use what? Dotted line. Understood? And for doing generalization now, what is that I written? Superclass. For doing generalization, superclass helps you in achieving what? Generalization. And here notice, subclass is used for doing what? Specialization. You are getting it now. Finish now. So subclass is supporting you what? Specialization. From design point of view I am talking. Why do you use subclass? For adding or changing implementation, all that is correct. But from design point of view, this is how it is told. Understood? Now for realization, what data type you use? Interface data type. Understood? So that's about what? Inheritance story is a relationship. When there has a relationship, it is called as what? Association. And here we end up using instance variables. There what will you do when you want is a relationship? You will go for extending and implementing. But here what will you do? You go for making as instance variables. That's the support what we get. Now instance variables. Now see, clearly you will understand. Again there are two types. What is that? Composition, aggregation. Perfectly explained. No book, no encyclopedia will tell you this. I am telling you only purely of what? Experience. That's why it's very high level for you. Understood? Composition, aggregation. Now next. Here composition is indicated with the help of what? A diamond. Like this. UML representation. Aggregation is told in what? Empty it is. That's it. UML representation. Understood? Next. So composition is what? Actually complete dependency. Okay. Aggregation is what? Partial dependency. Understood? Like examples here. You will be doing what? Class university. And you'll have class department. Now what is the scenario? University and department is there. University has a department now. So what will you do? Department D is what? Instance variable now. As simple as that. You're going for what? Has a relationship. Now there are again two. Complete dependency, partial dependency. Now if there is complete dependency, okay, use class as the instance variable. Following. If you want to do partial dependency, what will you do? Superclass or interface. Partial dependency. You can decouple now. Yes or no? I showed you. You can use interface as an instance variable now. Just now I showing you what? You can use interface. Not only interface, you can use superclass as well as abstract class as an instance variable. You can use superclass or abstract class or an interface as what? Instance variable. When will you do that? When you want partial dependency, you can change it now. It's partially dependent now. As simple as this. So use superclass as instance variable. One condition. Second one what? Use abstract class as instance variable. Or third one is what? Use interface as an instrument. I showed you only for interface. That is applicable to all the three. As simple as this. Are you clear? Perfectly solved all problems now. Any other oops word you have heard? Check out in all books now the meaning of these things. Internet is your best friend now. Google it out. Find the meaning of all this. You'll never understand. All the words explained. Generalization, specialization, same underline. Generalization, specialization. Next part. Association, composition, aggregation, realization. Clear? You struggled all your life for understanding oops. Oops is one side. Oops actually means what? See, oops means four things. What? Oops means actually four things are there. That clearly you have to understand. Encapsulation, abstraction, inheritance, and polymorphism. These are four oops principles. Now there is something called as oops design principles. That's when these four will come. These will come. Oops is different. Oops design principles are different. Understood? Oops means four. And again, all these are four are supported for what? Reusing and avoiding complexity. R&A. Reusing and avoiding complexity. Simple as that. Clear? Any difficulty anywhere? So what is important? Only that I'll return here. Rest I'll clear it off. So this what I leave on the board now should be what? A snapshot in your mind from today till you will code in industry. Perfectly I have left what is very important. This should be a snapshot. Understand what do you mean by snapshot? Never forget this. I'm moving away from camera now. See. Don't see me, see this. So important it is. Clear? Any questions? Oops over now. Perfectly I taught you oops. Within what? 45 classes. Oops actually I covered in only 25 class. Check out. 25 class. You have studied 4 years of engineering. Still you don't know proper oops. 25 classes I covered oops for you. Clear now? Any questions here? Okay. So this I told you will understand later. Do not bother much about this in interview. That's why I told you before in hand. Do not bother much about this in interview. But when you get experience, these are very important points. Understood? Interviewer expects to talk you in these terminologies. That time you will understand how to talk because every day you will be coding now. You will understand it. As a fresher you don't bother much about this. Keep it as an information. Shall we clear everything? Okay. One more document I'll give. That also is very important. It's the same thing. What? User defined data types only. But theoretically I have explained. More points are there which you will not understand now. They come with experience. These are my experience points I'm telling. 10 years of experience we have got now. 10 or more. Okay. With that experience I'm covering the subject for you. Are you clear? Some more I'll show you. Shall I clear all this? See, Java has 4 user-defined data types. You know that for implementing oops. The advantage of the 4 data types are, this is also not important from fresher point of view. When you get experience, you'll understand these points. Okay, when and why they are used. See, one is class. This one you know, it's very simple. Class you don't have problem. Subclass also you don't have problem. Okay, what is subclass? Class you understood now. It is used when you want to write new concrete implementations. Subclass, yes, this also you know. It is user-defined data type which can be used for implementing oops. It is used for doing what? Inheritance or inheriting the functionality of one class into another class. It is used for adding or changing implementations to existing class. It is used for modification of existing class. It is used for specialization. Yes or no? Superclass is used for what? Subclass I have written. Sorry, sir. Yeah, specialization. Subclass is used for specialization, whereas superclass will be used for generalization, and it is used for doing inheritance. It is used for establishing what? Is the relationship between classes. That point you'll start understanding clearly now. Understood? Next, abstract class also, there's no problem with abstract class also. Okay. It is a user-defined data type which can be used for implementing OOPs. It's used to provide partial implementation, leaving it to subclasses to complete the implementation. It is used for setting standards for the subclass to complete implementation. It is used for doing generalization. Abstract class is used for what? Generalization, because it's used as superclass. Understood? Sorry, I forgot to write there. Generalization. You can write superclass, comma what? Abstract class you write in the diagram. That one thing I forgot. In generalization, you have written only superclass now. Write there, comma, abstract class. Comma, abstract class. Okay. It is used for doing what? Generalization, and it provides the standard for what? So see here, abstract class is used for doing generalization. Interface is used for doing realization. Note the difference. Abstract class is used for doing generalization. Interface is used for doing realization. Understood? Fine. So then it is used for doing, and okay, fine. It is used for establishing is a relationship. Fine? Fine. Next. Yeah, interface is the subject. Those three you understood. Interface looks very simple. Most powerful data type. I told you, it takes days and days for you to understand it. Now you only see. Some points you already know. I already covered. Okay. Some terrific points are there. So that's the brilliance of the interface data type. Because of this rich data type, Java is very powerful. But you neglect this data type now. That's the reason. Okay, you find that's the problem with you. Because you neglect which one? You always concentrate on what? Class. What is class? That you concentrate. Very powerful data type. Start seeing. First point. It is a user-defined data type for which can be used for what? Implementing OOPs. Interface supports what? Multiple inheritance. Okay. It is completely what? Open for implementation. It does not contain any implementation. It is used for decoupling, declaration, and implementation of methods. That also you know. It is used for setting standards for other implementing classes. Correct. Interfaces specify what to do, but not how to do. That also okay. It supports what? Dynamic polymorphism. That also okay. Next what? It provides high level of abstraction. That also okay. It is used for loose coupling. Means what? Aggregation. Aggregation. Understood? Or decoupling the dependency between classes. Avoid interdependency when there has a relationship. Next, before Java 1.5, interfaces are used to write what? Constants. Some extra points which will start now. Okay. It is used for establishing is a relationship. It is used for doing what? Realization. Abstract classes are used for doing generalization. Interfaces are used for doing realization. Okay. But do not tell this point in the interview. You can't justify it. Other points you tell, which I gave yesterday. They'll ask you what is generalization and realization. You will not be able to answer. Understood? It will come with experience to you. That's what I told you. Okay. Next. It is used for establishing. Okay, fine. In projects, developer use interface for what? Now these points in projects when you'll understand. It's used for decoupling layers. Some extra points now. Okay. Example: DAO layer from service layer. Service layer from control layer. In projects now in your code there will be layers. So if you want to decouple the layers now, we start using what? Interfaces. Okay. Then more. See, if multiple programmers are working in different module of a project, they still use each other's API. API means the full form application programming interface. That you'll understand later. Understood? But if multiple programmers are working in different module of a project, they still use each other's API without knowing the implementation. They'll not be knowing, but still they'll be calling the method. And later on they can attach the object. Okay. This brings more flexibility and speed in terms of coding and development. Understood? Then next, interfaces make the application more flexible and maintenance easier. You have never seen an application, so where do you understand this point now? Understood? So those who see applications can clearly understand these points. So that's what I told you. It comes with experience. Next point, it is used for setting specification. That you know, but see here. Sun uses interfaces to set specification for all vendors. Sun is using interfaces to set what? Specification to all vendors. There are so many vendors. Next I'll show you. Okay. So it is using interface to set specification to all the vendors. Okay, next. Say example. There are so many vendors. Which are the vendors? See here. Server vendor, database vendor, persistence provider vendor. So many vendors are there. Okay. For every vendor, they will set the standard or specification. See, for server vendor, okay, see here, Sun uses interface for setting standards. API, it's called as API. When Sun sets a standard for other vendors, no, it calls it as what? API, application programming interface. We'll see what it is later for many vendors like, because that's the next technologies we are going to learn. This is what next we are going to learn, Servlet, JSP. So when we are using that, learning that technology, there we'll be learning what? Their library. Now how will they build the library? Using class, subclass, abstract class, interface, same story will start. Understood? So let's see. See, server vendor, Servlet API. Means for the server vendors, these are the specifications. It is broadly classified as Servlet API, JSP API. JSP full form is what? Java Server Page. API means Application Programming Interface. It's a full form. Java Server Page Application Programming Interface. Next, JSF API. EJB API. JSF means what? Java Server Face. EJB means what? Enterprise Java Bean. Okay. Then these are the specifications for server vendor. Now for database vendor, what is the specification? JDBC API. Understood? For persistence provider vendor, what is the API? JPA, Java Persistence API actually it is. Java, the full form is Java Persistence. A stands for what here? API itself. Okay, JPA, I have written API, no problem. Java Persistence API. Now fine. Lastly, it is a data type which can be used to interact with third-party classes and objects. I'll use an interface and I'll work with somebody's object. Third party. So all these extra points what you saw, you'll be understanding when you start coding later. With experience you'll get these points. So that is the advantage of an interface. Clear? Sounds alarming, no? So much about an interface. Huh? So always interface is the easiest to see but toughest to learn. Imagine it is not supporting, means it is not having so many members. If it was supporting multiple members with those many things, plus this one means, understood? Imagine. So just a simple data type which looks very simple, but so powerful it is, unbeatable it is. So Java is very rich in user-defined data types. We are done with this. Okay. From next class we'll start seeing more things. Okay. Next is simple packages and all. We start off. Clear? Any questions you are having? If you have question also you can't ask. Why you know? Your tongue will not twist. Understood? Because they are very powerful terminologies. So that's why I told you, you tell these statements only when you get experience. As a fresher I told you, table. As a fresher you are addicted to what? Tables. Difference between this, difference between that. When you get experience, these points will become important. Write it down. Okay, after 1 year or 2 years when you are changing companies, use these statements. They'll be really, really helpful for you. Especially this class which I take now. Understood? Okay, that's it.